On behalf of GLODEM and MA-CSSL, I would like to welcome you all to the third seminar of the AI and CSS seminar series. Before I present our speakers today, I also would like to take this opportunity to briefly present our series to those of you attending for the first time. AI and CSS seminar series brings together practitioners working on AI usage in various fields and scholars specializing in computational social sciences. If you would like to also receive news on our events, or if you're also interested in the other events hosted by GLODEM, you can sign up for the global GLODEM mailing list. I actually would like to share my screen with you to also show. My screen. So here you can access the events of both GLODEM and the AI and CSS seminar series is also listed here. With that, to give that privilege to, I think you can share your screen also now.
Okay, can you see my screen?
Yes.
Okay, good evening. This is Erdem from Koç Sociology Department, and I would like to thank Mary and GLODEM very much for inviting us, and I would like to thank all of you for joining us today. We are truly thrilled to share our project and findings with the computational social science community in Turkey, and we see this an excellent opportunity. And we are looking forward to feedbacks and questions for this project, for which we have been working almost like 4 years. We started in 2000 and like 4 years ago, exactly 4 years ago. Okay, so let me start our presentation. So our presentation has 4 parts. First, I will do a brief introduction. Then Charlie will talk about the ethical aspects of our project, which is extremely important for us. For many studies, it is usually considered as a marginal aspect of research, especially for this business of protest collection and conflict. Scholars do not have much interest in these ethical aspects, especially. So, and then in the third part, Fırat will talk about how we conduct the annotation process, and this is also a very critical aspect of our project. And then Ali will talk about the results and more technical aspects of the artificial intelligence methods that we are utilizing. So this project is the general title of the project is Emerging Welfare, and this has been funded by the European Research Council. And the main question here is about the welfare state development in developing countries. I'm not going much into detail, but the main thing is that most scholars were expecting a withdrawal or a retrenchment, radical retrenchment of the welfare state during neoliberalism. But when we look at the most developing countries, and especially the so-called emerging markets, we see that during the neoliberal era, these countries have expanded very generous social welfare programs. And neoliberal era has become the period in which the welfare state has been radically expanded and established in the first place. And so this is a puzzle. We are looking for reasons why this welfare state expansion is happening during neoliberalism. And our first research question is if there is such a big social welfare expansion, and especially on the basis of very expensive and generous social assistance programs, does this correspond to a new welfare state regime structure? This is a welfare social policy literature. I'm not going into detail, but if emerging markets are forming a new welfare state family typology, this is our first question. And using other quantitative methods and other data sets, we have confirmed our first hypothesis, and we call that new welfare state regime the populist welfare state regime. The second question is related to welfare state development. Why is then this welfare state expansion is taking place? And our main contribution or challenge is that so most of the literature is looking at structural factors like economic and demographic factors to explain rapid social assistance programs. And they are underestimating the importance of political and especially contentious political factors. Yes.
We don't see the presentation. Are you sharing it?
Yeah, I just actually messaged you. Didn't want to interrupt. The screen sharing is off at the moment. I don't know if that was a glitch maybe in the system.
Can you see it now?
We can see it now.
Sometimes when yeah.
Yeah, I just see my PowerPoint screen. I don't see any face, so just interrupt anytime there's a problem. Then you didn't miss much, but but you can hear me, right? So there was no problem about that.
Yes.
Yeah. Okay, perfect. So the second thing is that that literature has mostly looked at economic and demographic factors, and therefore they underestimated the importance of politics and contentious politics in particular. They underestimated the importance of social unrest, protest, and social movements in general. Okay, and so our main basic question is, what is the cause of welfare state expansion in emerging markets, and does contentious politics play any role? And we define contentious politics as the total sum of like street demonstrations, industrial actions, group clashes, and so any movement that is challenging the political authority with certain demands and grievances. Therefore, our definition of contentious politics is rather broad. And our project is highly quantitative. Therefore, our main dependent variable is welfare policies, and our main independent variable is contentious politics and protest movements in particular. Therefore, we have to quantify protest movements. And for the countries in question, that kind of quantified protest data sets did not exist. Therefore, we had to create our own data set. And the protest data sets, social movements data sets, have a long history going back to the 1930s even, and that scholarship mostly relied on manual ways of extracting protest or social movement data from newspapers. And newspapers have always been seen as the most reliable source of protest or social movement data. These days, social media has also joined newspaper archives as the second source of protest information, obviously. And that scholarship has been mostly manual, and from Charles Tilly to Beverly Silver, and currently there's this big project, ACLET, which manually collects conflict information from a wide range of geographies in the world. And as you can imagine, it is high quality, obviously, and this is the main advantage of manual methods. But manual methods are not born out of this high quality, but it is born out of necessity, because until recently there was no other way of doing that. And it is the problem is that it is really expensive and time consuming, and it is not replicable. And if you change the definition of your protest events or a new protest typology comes in, it is too late to change everything. And automated methods came into the picture out of this need. But the reality is that this automated methods has become a feasible alternative only with the rise of the artificial intelligence and big data revolution. And with the increase of the rapid increase in the computational power and the rapid digitalization of news archives, have made automated collection of protest events a feasible alternative to manual methods. And very large projects have come into existence. The most important one is GDELT, and that we also have ICEWS, Mass Mobilization and Autocracies, and another risk fund, POLCON. So these are automated, these are projects that use automated methods from a varying from a spectrum of the degree of automatization. For example, GDELT is a fully automated system, both classification and protest classification and information extraction parts are automated, but it is rule-based. It has low precision, and it is recall performance is even unknown. ICEWS, this is a project supported by security agencies. It is also fully automated. It has a high precision, but its recall is really, really low performing. MMAD, MMAD and POLCON, these are also recent projects, and they do protest classification task in an automated way, which means so out of a huge newspaper archive, their tools can identify which news articles contain information or they are about protest events. And once they identify these protest-related articles, then a team of human annotators continue to extract and protest characteristics.
Adam?
Can you hear me now?
We can hear you now.
Now, yes.
What did you hear last? GDELT, ICEWS.
We actually
we heard
for a brief moment. For like 2 seconds. We just lost you for a brief moment. It was only for like 2 seconds. So.
Okay. So all of these projects suffer from reliability and validity problems. And the most importantly, if you are interested in cross-national protest event collection, you observe a very diverse set of protest characteristics across different countries. And as I said, most of these projects do not use machine learning based real AI methods, but even if they use, for example, POLCON and MMAD, they are using these methods in their classification task, but they are using keywords to identify the training materials that they use to train their machine learning algorithms. And as Ali will talk later in more detail,
Hojam, you're frozen again.
His connection is not stable. Let's double check.
Sorry again.
Hojam, the last word you said was Ali will talk about that later.
Yeah, Ali will talk about that later on, but let me share my screen again. So the use of keyword methods lead to a lot of disadvantages. So I saw that most of these projects are far away from generalizability. Therefore, what we develop in this project is a generalizable and cross-lingual and cross-context generalizability. By context, we refer to cross countries, cross languages, cross time, and cross languages, and cross sources, different newspaper sources. And in order to attain cross-context generalizability, we argue and we do that, you select your training data by using random sampling. Okay. And Ali will illustrate this by a set of comparisons, empirical comparisons that we have conducted. And another problem in the literature is that there is no gold standard corpus in that protest event business literature. And this is extremely difficult, and Frat has done an excellent job for the last 2 years or more to make sure that we really have the first real gold standard corpus in and publicly available, transparent gold standard corpus in automated protest event, the scholarship. Therefore, we try to reach at a cross-context generalizability in our efforts. So what we do briefly, so we are using artificial intelligence, but what? We are using natural language processing and machine learning and state-of-the-art deep learning algorithms. And our algorithm, our tools have 2 parts. First of all, we do classification. We have access to all digital archives of several news archives from several countries that we are interested in. Which countries that we are interested in? India, China, South Africa, Argentina, and Brazil. And we are doing this, let me go back to this slide, but so we use local news sources and we use international sources only if there is a need, there is a problem with the local sources, which is a critical thing. If in the case of China, there is a lot of state censorship on local news archives. Therefore, we are complementing our data set with English news sources. But otherwise, we are trying to, and we are leaning on local national news sources as opposed to like New York Times and Guardian. So this is also another problem with the existing scholarship. They mostly rely on international sources. And we do these annotations and we do this protest collection in 3 languages, English, Portuguese, and Spanish. And the countries that we are interested in are China, India, South Africa, Brazil, Argentina, and then we will continue with Mexico and Colombia. And from India and China, each of them, we have collected more than 10 million articles from each country. For example, from India, we have downloaded the archives of 3 main newspapers. And then in that classification part, what we do, we randomly choose 10,000 articles. And we have an excellent team of PhD and master students at Koç University. And I would like to thank them once again here for their excellent job. And they have, and we gave them training, and Burak Gürel, Professor Burak Gürel from Sociology Department, and he is an expert on China and India, and he speaks Chinese very well. And so this is an excellent asset for us, because as you know, computational algorithms and computational power is itself is not enough. You have to have extensive domain knowledge in if you want to have a really good job. And you need experts on the team. And without Burak, for example, we would never be able to conduct this research. And he provides domain expertise, and he gave extensive training to our annotators. And at Koç University, we ensured that our graduate students were able to annotate protest events and protest information from Indian and Chinese and South African news archives. And this was actually really important, and the really high quality of graduate students made this possible. And then, so this out of, so we randomly choose 10,000 news articles, and usually 5 to 8% of all news articles in the countries that we are interested in contain protest information. That means out of this 10,000, 800 or 900 of them are classified by our annotators as protest-related articles. Then we use this training data set, like 800 positive and 9,200 negative cases. We use this training data set to train our machine learning algorithm, and which with a really high performance is now able to predict the protest events in the rest of the archive. And then once we identify the protest containing research news articles, then our team of annotators continue with detailed information extraction. Using a specific software, they did detailed annotation, the protesters, type of protesters, organizers, ideology, violence, urban, rural, place, time, location, etc., etc. They identify, they annotate a really wide set of characteristics. And then in the second part, our machine learning algorithm is being trained with this detailed training data set, so that it can predict protest information later on. And therefore, we developed the first gold standard corpus in cross-national context, automated protest event collection. We use a representative sample of news articles as opposed to keyword selection. We do double annotation in our annotation process, and Frat has been greatly doing the adjudication parts. And whenever there is a conflict between two annotators, then he was resolving that conflict and correcting the annotation. And this, and therefore, every single article in this data set has been double annotated and adjudicated. This is a really, and whether or not the output is successful in terms of sociology or not, this was actually a big contribution to the domain of computational linguistics. And we do this annotation at the document and sentence and token levels. And I think, yeah. And I was talking about that, but so we collect the news archives, and then we classify protest events information, and then in the second part we identify the sentence that contains the protest information. Then we extract event participant, place time, other characteristics, and we also do semantic categorization of, for example, event types. So what is the output? So the entire the protest data set, we call this protest data set GLOCON, Global Contentious Politics Dataset. And we are releasing this data set very soon. The part on Turkey has been conducted manually, because that was I started this Turkey data set as part of my PhD project. I started this in 2010, and then with the support of the Marie Curie grant and with the ERC grant, we have updated and corrected this data set, and now we have a full Turkey protest event data set for the time period between 1970 to 2000 and I think 17 last year. And this is done manually, but except for Turkey, all other countries will be done using automated methods. And so we will share this data set, and we have worked extensively on the data visualization, and Mutasam is also here, and he is a computer scientist and MA student, and he has done an excellent job in designing this this website. But we also have other team members, for example, Damla, so she has helped us for the visualization aspects. And in this website, we will be able to classify, so we see, first of all, the time series like trends in protest events and the geographical distribution of protest events. And then we can filter protest events in this map and in this timeline by event types and by participant types, by organizer types. And then we can visualize or color these circles by event, participant, organizer, etc. And what and this is a really small example, but from India, for example, this is one of our very crude outputs. The total number of protest events between 1997 and 2015. I forgot to put the benchmarks here, but I like this because it quite strongly resembles existing manually coded data sets on India, and it shows that we are so far doing a good job, and so we are not failing. There is no logical inconsistency in the main trends of this timeline. Yes, this is the end of my part, and now it is Çağrı, so she will talk about the ethical aspects of our project. Thank you very much.
Thank you, Hocam. Hi, thank you, Erdem, and thank you, Mary, for organizing this event, and thank you all for joining us today. For those of you who have missed the introductions, my name is Çağrı Oltar. I'm a postdoctoral fellow and the project leader of the Emerging Welfare project here at Koç University. And today I'll talk about the ethical dimensions of our GLOCON research. So let me share my screen. Just a second. Yes. Okay. Can you see my screen?
Yes.
Yes, Hocam.
Okay, great.
So as Erdem explained in detail, our project seeks to contribute to the protest database building methodology by improving the cross-context generalizability and performance of automated classification and information extraction tools. As social scientists who are well aware of the complex politics of knowledge production and who take responsibility of the knowledge produced, we developed some protocols to ensure the ethical use and sharing of the protest data we collected by computational methods. So unfortunately, ethical issues remain marginal to protest database production efforts in general. Most projects do not address ethical issues that may arise from their work at all. But in fact, any protest dataset creation project demands special attention to ethical dimensions of research because of the risks associated with political dissent. For instance, compiling information about contentious activity may disclose some key actors and dynamics of political dissent, or protest datasets may make protest trends visible and enable predictions of future protest activity. In other words, due to the sensitive nature of the information these datasets make available, they may render activists or insubordinate populations vulnerable to further surveillance and repression. This risk, which pertains to all protest database building efforts, including those using manual methods, is aggravated with the use of automated tools. This is because automated tools allow for the processing of large amounts of information in very short spans of time and enable the production of almost real-time trends of contentious event activity from online news sources. At GLOCON, we take the risks that political contention research might pose to activists and precarious populations seriously, and we strive to develop strategies to mitigate these risks and address ethical concerns about social movements research as much as possible. So, the question of ethical dimensions and risks inform actually all stages of our research, including research design, data collection, and analysis and dissemination. The first question we address in this regard is about the relevance of our research to research subjects, that is, social movements, activists, and precarious communities that engage in contentious activities, as well as to the scientific community. As Erdem explained, the GLOCON is part of a larger grassroots political activity, and as Erdem explained, the GLOCON is part of a larger research project, Emerging Welfare, which investigates the causal relations between grassroots political activity and welfare state expansion in emerging market countries. We collect and analyze protest data from our case countries for the purpose of revealing dynamics that inform social policymaking processes and assessing the impact of grassroots activism and organized politics on government policies. This is to test our argument that most governments use and expand social welfare programs in their efforts to contain social unrest and establish political stability. In this regard, our research produces data and knowledge of relevance to both scholars and also to social movements themselves, as it provides social movements and activists with intellectual resources and data about the impact of their activities on social justice. The second ethical concern we address in building GLOCON is about the protection of research subjects in the data processes of data collection, analysis, and dissemination. As I explained earlier, automated protest data collection may pose significant risks for research subjects. The methodology we develop in the GLOCON allows us to compile fine-grained protest event information, including organizer and participant information, as well as event place, event time, and event type information more accurately than other automated event databases, and more easily and cost-effectively than manual methods. Therefore, it requires us to take further precautions to prevent access to and use of these data by malicious actors who may target resistant groups or individuals. As a first step to protect the identity and activities of research subjects, be it specific populations, groups, organizations, or individuals, we store our gold standard corpus, automated tools, and protest datasets in encrypted hard drives. Secondly, in data processing and analysis, including the creation of ontologies, semantic categories, as well as the production of social science articles, we refrain from disclosing the identity of any specific individuals. And also we refrain from using derogatory, stigmatizing, or criminalizing language, such as terrorist or bandit, in our categorization of contentious activity or actors. Instead, we use value-neutral and factual terms, such as armed organization or armed militancy or militant, in categorizing protest participants, organizers, or event type data. Besides these ethical standards we rely on in data collection, processing, and analysis, we develop specific protocols of data sharing to minimize the risk of use of our data for malicious purposes against activists or resistant groups. Our data sharing policy is shaped by our belief. I'm sorry, just a second. Our data sharing policy is shaped by our belief in the power of scientific collaboration and research transparency for theory and method development, as much as our concern about the well-being of precarious populations, groups, and individuals that are engaged in political activities for social change. In order to balance these sometimes conflicting priorities, we have embraced a two-tier data sharing method. At the first layer, we share the processed and limited version of our data in a visualized form on an open access website of the GLOCON project. The protest data visualized on country maps on this website provide only macro level information about the main protest categories. At the second layer, we share our detailed protest data sets and our gold standard corpus and computational tools only with researchers and parties, including social movements themselves, who demonstrate compliance with ethical standards of social movements research and norms for the protection of research subjects. For instance, we do not share our detailed data with government or law enforcement agencies or researchers who collaborate or receive funding from intelligence or defense agencies. In addition to protecting research subjects, we also develop strategies of sharing our corpus without violating the copyrights of news sources we use in developing our tools and building our protest database. Copyright protection is actually an unresolved issue in the automated protest building business addressed by leading scholars. So we are trying to be innovative in this regard. For instance, in the shared tasks we organized, our computer science team engineered methods of sharing part of our gold standard corpus with other participants to run their tools without causing any copyright violations. This involved only sharing information that is needed to reproduce the shared part of the corpus from the source of classification tasks, sharing only the news article URLs, and only relevant snippets from annotated news articles for information extraction tasks. This innovative data sharing method has worked successfully, and our computer engineer colleagues published the details of this method in an article. If you would like to learn more about this copyright protection method our team has developed, you can get in touch with Ali Hürriyetoğlu. And also, if you have any questions or comments about the protocols we develop for ethical data use and sharing, please share them with us. We really appreciate any feedback, any of your feedbacks. Now, I will leave the floor to my colleagues, Fırat and Ali, They'll talk about the details of our protest information retrieval method and explain the technicalities of our annotation and corpus creation methods and discuss how our method performs in comparison to others. Fırat and Ali, the floor is yours. Thank you.
Thank you, Ecem.
Thank you, Chowder. I'd like to welcome you all to the session, and thank to the organizers for giving us this chance to talk about our project. I'd like to apologize for a few minutes because I'm having some problems with my presentation. I don't think I'll be able to make it full screen, and I'm going to have to pass the slides manually. But sorry. I was trying something with the presentation settings, and apparently I messed something up just 2 minutes ago.
Take your time. We have been having some technical issues today, by the way. Caner Hoca, the director of GLODEM, was not able to join us because of that somehow. He couldn't log in with the passcode provided. Maybe there is a certain glitch in the system. I don't really know what's happening, but my screen also kept freezing when I tried to share my slides today. So the full screen mode didn't work for me either. If it's the same slides that Ali Hoca will be using, maybe he can share his screen. Would that work for you?
No, that wouldn't work for me because he doesn't have the file. I'm actually trying to.
You can send me an email if you want.
Yes, let me go ahead and try to do that.
Maybe in the meantime, you can get some comments or questions. I don't know.
Yeah, that would be great. If you have any questions for the presentation so far, you can write that in the chat box or just unmute yourself and ask any clarification questions maybe. I guess everything was pretty clear then. Thank you.
Actually, the problem is I really do apologize for taking everybody's time, but
maybe we can continue with Ali, then you can talk about that later.
Yeah, I was going to yeah, maybe that's a good idea.
Okay, I will try to share. Yeah, I guess the settings are somehow different this time. It asks for an email and login kind of thing. So I got another email about the person who can't log in. This is maybe some experience we should keep in mind in the settings. Hi everybody, do you see my screen by the way?
Yes.
Perfect. Hi everybody, I'm emw.ku.edu.tr, postdoc in Emerging Welfare Project and responsible from this technical work package. I would like to provide a brief information about our results and our experience. Adam, Chada, and Fırat has already said a lot, and hope Fırat will be shedding light on most critical aspect, but because when the definitions and ontologies are there, computational part is much more easier. So a couple of highlights from our work for 3 years. Quality of the standard, gold standard corpus. Otherwise, whatever you measure, basically you can't measure anything if you don't have a good benchmark data set. When we started to with summer plan, we had to change our plans based on the first iterations of the annotations. It is quite natural in this kind of work because when we start with the domain knowledge and face the data, we need to come back and adjust it. This is one of the advantages of this kind of approach, automated one, I mean. So we had the flexibility. After we have some knowledge, that's encoded on the documents, we could use them. We could use this information to make our pipeline more efficient. So it was active learning. And then next comes how generalizable is our models, because we are dealing with at least 20 years period. What if we train a model that works for today, for, let's say, we optimized it for last 20 years. Will it work for the following year? Maybe ratios of the event types will change, maybe new type of events will emerge. So how can we ensure generalizability of our models, machine learning models, I mean? And this is, again, for different countries, different dialects of the same language for different languages. Therefore, because it covers that much, we use the cross-context term. Another important aspect is the keyword versus random sampling. Till now, all evaluation, test, and tool development is based on keywords. So some domain experts go there, check some data, create a list of keywords. They have 5 million news articles. When they use this, when they filter millions of, 100 millions of news archives, POLCON did this actually. So they had 5 million news articles. They want to annotate it manually. So they don't know what they left out, this 95 million. And they evaluate all their approaches on this 5 million. And they had to make additional, like many rules to decrease the number to 35,000 because they had the budget to annotate 35,000. So they don't know what they miss. We are in close contact with them. Thanks to them, they helped us a lot from the very beginning. But we, from these lessons, we tried to not make the same thing. So it was some warning for us. We started with random sampling, and after we did our work and compared it, we saw random sampling when we use state-of-art deep learning approaches like BERT. Those are pre-trained architectures, so they know a lot about the context of the world. World of knowledge is encoded there as extracted from text. Actually do much better in the cross-context setting because they know a lot of, because in machine learning, it is important to know what is relevant, but it is equally important to know what is not relevant as good as possible. Because it is at the end determining the decision boundary between two classes at least. Then the cross-lingual generalization, we want to use how can we do all this how can we use the information we have already in English and apply it to other languages? Otherwise, we don't have an ERC project every time we want to do a new language. And scalability. So how we can do all this stuff. The prediction time, training time is quite long. So processing 1 million corpus takes 30 hours on 8 GPUs. So again, it's excessive. So what kind of stuff we can do? First, we talk about those. Corpus quality is at the highest importance. Like internet annotated agreement should be as good as possible. Annotation supervisor should be solving the disagreements, spot checks, semi-automated corrections, all are in place to hunt any error or any inconsistency, either in the annotations or in the annotation manual. So, and automation helped us to go back and forth to make sure everything is fine. The internet agreement at token level is a bit trickier, so therefore these numbers somewhat lower, but those are all corrected or improved in other processes. These agreements, Crependor's alpha, in terms of Crependor's alpha, are the basic annotator annotations. So we discovered 2 tasks. The sentence level annotation task without this, in comparison to our initial plan, I mean, 2 new tasks. If we annotate documents and then go to token level directly, annotation is much less reliable because there is a lot of freedom or space for ambiguities or annotator doesn't agree. Again, the same thing in tool development. So we injected the sentence level annotation tasks. So we annotate every sentence that it contains the event information. So we call it event sentence and event coreference. So the assumption in the field is to have 1 event per document, or use only the leading sentence or first 6 sentences at most. So, but when we have this random sample, we could check like how many events are there in a news article. So 41% of the documents has more than 1 event. When we check whether every sentence really about a separate event, it is only in 35 of the cases. In all other cases, an event description or report contains at least 2, sometimes 3, even 4, 5 sentences. So information should be gathered together. So when we annotate a random sample, only 5% is positive about relevant events. And this means 20 annotations for 1 protest report. So it's not scalable and no budget can really cover everything, all these effort to scale that much. So after a couple of iterations of random annotations, we just started every time we have new data, we train our model in a recall optimized way. I mean, in an it is optimized not to miss anything at the expense of being less precise. Luckily, precision was only dropped only to the 60%, which means annotator starts to check 2 documents to be able to get 1 positive document. So it helped us a lot to get much more positive information without missing much information. Yeah, so this was a trick. We make our annotations really be a lot without losing the recall. But every time we start a new resource or country or language, we certainly annotate at least 1,000 documents which are randomly sampled, just to have our benchmarks or evaluation setting. if we do any automated deep learning, AI, whatever, to be able to check what is happening there. Otherwise, if we keep filtering those, we may lose our sight after what is in this 3%. These results are from our shared task about cross-context generalizability. So what would a model that is trained only using data from India do on data collected from China? So test one means from the document classification on India, and this is sentence classification. Sorry, this is again document classification, but on sorry, it is like 81-70. So the performance from India to China dropped 10 points. It is a lot for F1. This is for document level, and this is for sentence level. From 63, it drops to 60. Those are the best scores. We have the overview paper, full details are there. But this showed us whatever you apply, there were 13 teams joining these tasks. Whatever technology on the world you apply, you will lose this information. But some approaches are better. Like gated recurrent unit, ELMO, BERT was not that popular. We didn't have any BERT result, but our own in-house models were exceeding those. So we know we were the first adopters of BERT, which really did a lot. And any other development didn't change. It wasn't the major breakthrough lately. For task 3, the token classification, again, BERT was not around, and the best was BILSTM plus CRF. And again, you really lose 7 points. If you lose less between India and China, it is better. So we have the average to rank the submissions. But this showed us the importance to keep in touch with the international community. And since then, almost every year we suggest these tasks. Lately, it was a co-reference task to identify whether two sentences are about the same event or not. But based on this cross-contextness, whether things really generalize, we checked whether keywords do better job or comparable job to random samples in cross-context settings. We had 4 keyword sets from prominent studies. Even Wang et al. Was evaluating major databases. So the purpose was to evaluate what is there. So you lose, this is no information retrieval community as well. If you use keywords, what keyword you use, it is the best recall you get, or F1 you get, is around 80%. So you lose 20%, and what is in this 20%? There are 10 strong, we can share the details, that marginal events are not known, or events by minorities, or new kind of events. So I think that is not popular or not in the mainstream media is lost with this kind of approaches. So, but what would happen if we apply this to the cross-context setting? So the best keyword set, this is POLCON. We compared when we checked their coverage here. Its recall is the highest, 81. These guys are quite good at this methodology, so they really do a good job. You should read what they do. Based on this filtering with keyword list of POLCON, it is when we train on India and test we didn't take on India, on those are the scores. But if you use the random sample, these are the scores. So you have every time at least 5 to 10 to 15 points better if you use the random sample. There is only one case where they have comparable results. Can I spot it here? It was about South Africa, if I remember correctly. Anyway, 1 out of 6 cases, and in average random, 5 out of 6 cases, and on average, random samples are superior. Before it was okay to use keywords because the machine learning methodology, which we all tested as well, was performing much better when you use keyword sets, big keyword filtered sets, because those are balanced data sets, and traditional machine learning could do a lot with those. But a random sample would be an imbalanced data, and traditional machine learning can't cope with it. Therefore, you will get much less scores. We have this as well, but just not to make it included. So it was fine, okay to do it before to use keywords. But when you have these pre-trained contextualized embeddings, it is time to switch to random samples, because you don't need to blow or inflate your positive count. So the cross-lingual generalization, there are multilingual models of BERT and a couple of others. And what if we want to use our data prepared for India and China and South Africa in English? What would be its value for our work on Brazil or Argentina? So if we use, we try to normalize the numbers, so therefore we have these numbers here. If we only use English data, it performs 75 Spanish on Spanish data. This Spanish model, when you have 2 versions, when you use Spanish data on the Spanish model, because BERT models have 2 classes, either it handles either one language or cross-lingual. So on the left, we have the cross-lingual one. On the right, we have the single language ones. So just to see whether there is a big difference. So the Spanish one, like slightly better than the multilingual one. So this shows us like this could be one methodology that we can invest in to cover as many as possible languages. And this BERT multilingual handles 104 languages. So any data point we have in any language can be included in the training set. Here we say all, no limit. When we use, for instance, on the multilingual, using the multilingual BERT, using only Spanish data, the predictions will be like this, like 83, comparable to the single model, Spanish. Again, comparable, slightly less for this when it compared to the single model one. And when nobody can stop us from merging all this data, and then scores even better. So whatever we did for English can be used for other languages. And if we have additional data, even it exceeds the English baseline. The single language English is 89, and it is 89. What is the difference here? I don't remember. Yeah, when you have less data. Yeah, do more data from any language, dialect, whatever, you just put them and you can get comparable results. So no, it doesn't matter much to maintain a separate model, separate pipeline for every different language. This is the message here. For scalability, there are this DLBERT version we can use. It is much faster, much less weight. We tested it, so it is comparable. And our power is mostly the quality of the data and amount of the data, so we can close this gap. Recall is important for us, so we use in the real pipeline F2, which gives more weight to recall without sacrificing the precision match. Overall results for our own pipeline is like this, like almost 90. We lose some performance on China, but we can optimize it on other stuff. Triggers are like this. We don't have time. I am looking, keeping an eye on the watch, so just not to repeat things. We want to understand what type of event is it, like is it unobtrusive, demonstration, group clash, or industry election. So those are the scores. We are quite good at some of them, but a bit tricky to get events that may co-occur, group clash and demonstration, for instance. Organizer categories, again, some of them much better when there is a semantically separate logic, then it can be learned better. But things that may get together or similar, then it will not work or will work less. We have participant categories, so, and we can just report the general category. Some of them doesn't work, so sometimes we check the confusion matrix and merge these with more general. So we just move to a more generic ontology. We did it for the organizers, but not haven't done it for participants. So what is next? The core reference stuff in cross document. We do our work mostly on the in document for now, but we have a master student working on the cross document one. Demand recognition, violence recognition, whether the event is violent or not. Cost in India, it's quite tricky and hard topic. We have been putting one bit every month, for instance, but we are consistently on it. Ideology classification, and hopefully soon a global database of protest events, which consists of as much as possible local sources, not a single source, but classified to different countries. Thank you very much for your time. I just want to be as quick as possible. Those are the events. Next year we have the workshop in the top competition linguistic conference. So it doesn't have to be technical. Please consider to help in share tasks or submit anything. And this will be our email list for our community building effort. And just reach us for anything. I can give the word to Fırat. I hope you will have enough time for yourself.
Thank you very much. We actually have about 15 minutes left, and we were hoping to also spare some time for the Q&A session. So if we could maybe move a little faster, that'd be great. So, because I know for a fact that we already have some questions in the list. So thank you.
Okay. Thank you. So I'll try to be as quick as possible. I don't have that many slides. I'm sharing my screen and the whole desktop. Okay. Can everybody see my screen?
No, we can still see. Is it the same slide you're using? Because I still see Ali Hoca's screen actually.
I should close my share.
You stop sharing. Mm-hmm.
Yeah, I stopped.
Okay. I was already sharing. Can you see my screen now?
Yes.
Yeah.
Okay, cool. So, well, I apologize again for the earlier problem. What I'm going to talk about is actually the human coding element, upon which all pretty much everything Ali talked about is based on. And all of my colleagues mentioned that automated machine learning models, automated test classification tools will be at the most as good as their the data on which they are trained and tested. So a crucial step in development has been the manual coding human annotation of the source material. So I'm going to talk about this annotation process on the whole. And the central place annotated data plays in automated tool development can be encapsulated in the phrase that as this is something we learned time and again: what cannot be annotated cannot be learned. It would be really difficult to automate a task which humans cannot do themselves consistently and properly. What is achieving? What is this ability to be annotated? So it is achieving consistency over a variety of dimensions. As my colleagues have mentioned, we work with in this project we work with multiple countries, multiple time a time period spanning a couple like almost 4 decades. So this in itself is carries a lot of variation that your tools need to handle, need to be able to handle in the end. So you have to on the annotation side, you have to label code the documents consistently over different contexts, over temporal and spatial contexts, and even in across different languages. And also, since this is a drawn-out project, it takes a considerable amount of time. The rules of annotation according to which you annotate, you should be able to apply them consistently over time as well, as new contexts are introduced, as you start working with new people, etc., etc. So these are all challenges in their own right.
Fırat, bir şey söyleyeceğim. Senin mikrofonun galiba yakana çarpıyor da. Onu eline tutabilirsen. Heh.
Okay. So, okay, I hope this is better now. So, in order to what we call the high quality annotated data is called gold standard corpus. So, how do you assure the gold standard quality? Well, first of all, we start with working with high quality annotators. As Erdem mentioned, they're all excellent graduate students in social sciences who already have a lot of information, knowledge about contentious politics events. So they are not only able to grasp our event definition easily and apply it masterfully, they also contribute their background into the whole process. So that's among the most valuable things in that respect. So, but still, they receive an extensive training whenever we start working with annotators. They are first and foremost trained in the basics of linguistic annotation, and obviously they're trained on what we define as contentious politics, the nuances that our definition includes, although we use quite a broad definition in that sense. And also we try to give them a country-specific background in contentious politics. We have worked with 2 excellent annotation teams so far. The one team was based in Turkey. They were graduate students at Koç University, so they were given background information, country-specific information on India, China, and South Africa, whose data they have worked with. And the second team that we had the good fortune of working with were graduate students in the University of Sao Paulo, which we partnered for this in the Emerging Markets Welfare Project. And they were also given this training and extensive training, and also they were given background on contentious politics on South Africa, Argentina, and Brazil, even though they were Brazilians, and they taught us instead of us teaching them on many aspects. So so when you have good annotators, when you start working with your data, as Ali and Ardam mentioned, we tried to sample our data, working data, randomly from raw data as much as possible, which means we haven't used keyword filtering. We just used the entire databases of our news sources. And annotation meant annotators have read every single news article in that random sample, which was independent of the fact that it being about protest or not. So they've read paparazzi news, they've had soccer news, what have you. And they, so this is the way we assured that we were working with truly random data and building the quality up from the bottom to top. In terms of annotation process, the annotation tasks follow the pipeline of our automated models, end result automated models. So we always start with random samples of whole documents. We classify them into protest and non-protest documents. So documents which contain protest-related information are given a protest value by our annotators, and those which don't, they're labeled as non-protest. So this is the initial step on which our corpus is built. So not going into very much detail in terms of tasks. So we worked in the following tasks in the pipeline. We work with the result of the first task. So if you have a positive document, you start annotating it in the second task. You start annotating the sentences of that document. So this is to determine where in the document protest information is relayed. So this is pretty much like a document classification task. It's a sentence classification task whereby every sentence is given a label, which is a protest sentence or a no protest sentence. So in the third task, we have the information, what we call information extraction, which is token level annotation on the token level. This is somewhat different. This is not a classification task. This is the very basic nitty-gritty and detailed work of going to each document and coding individual variables by hand. Just to show you a quick example. So this is how we work on the token level. So these are sentences. They are labeled previously in the previous level as event sentence. So as you can see here, we have the event reference attack, and this is the place that this event took place. This is the location, what we call facility, that the event took place. And this is also another event trigger. So on the annotation on the token level works in this environment whereby every piece of information that is related to the event are hand coded. So what we look for in events, Ali showed in results some of the variables that we work with. So our main focus is obviously the event. Every document and every sentence which contains an event reference is our positive case, and event reference is the verb or noun that refers directly to an event. So in this case, it would be exploded, or if in this case, Udhampur attack is, here attack is used as a noun, although it refers to the protest itself. So as to event, we are after its time, we are after its location, facility, whether the place is an urban place or a rural place. So these are the variables that we work with the event-related information. And also we have participant category. We tag participants. So here the operative is the person behind the attack. It seems this is not really very informative, but we tag it nevertheless. So we have an event here. Okay, never mind that. So we're after the participants, ethnicity, religion, ideology, socioeconomic status, employment status, and caste characteristics. So we label these whenever we have information about them in the text that we annotate. So we also have organizer. We work with same variables on the organizer, and we have finally the targets, the antagonists or adversaries of the protesters. So this this entire process is very detailed, and for each step of the way we have an annotation manual which aims to secure consistency. And that annotation manual is, well, usually in the ideal you would want an annotation manual to be ready, and you start a project and you annotate according to those rules, but it doesn't quite work like that. You come across corner cases, you come across certain instances where you have to define certain special cases, elaborate on rules, and you have to like update the manual, the rules according to which you annotate as you go along, as you work with new types of data, new types of contexts, and new types of people who annotate, which see different things, which who sense different angles of the situation. So you need to update your rules, but you have to do it in a way which doesn't create inconsistency. So you start with the same basic rules, you just elaborate them, adapt them, never change them. So this is how it works.
Thank you.
On the long run.
If you could wrap up, because we actually already passed 7:30.
Yeah. Okay. So just a quick note on. Okay, let me choose just one slide and. Okay, so actually these are all. Okay, in terms of how to manage annotation quality, these are already mentioned, but let me just give a few pointers on. We operate with something which is called a reasonable reader rule, which means that every single person would, to the best of his or her ability, will interpret the given sentence in the same way. So how do you assure that? You use two annotators annotate the same text, same sentence, and you compare their agreements and disagreements. We considered the disagreements and errors that they make as feedbacks rather than mishaps all the time, according to which we updated our rules in order to minimize the mistakes and disagreements in the long run. And thus we used the annotation process as a feedback mechanism to improve our task designs as well. As Ali talked about, we learned a lot of things along the way. We modified our models, both machine learning models and our general task design. And this was all possible due to the feedback that we received from the annotation. So yeah, I hope I could be clear. This was kind of fast, and but that's pretty much all I'd like to say. So thank you.
Thank you very much. Thank you all actually for this really informative presentation on, as I said, a very inspirational research. Unfortunately, we're past our time, but if you have maybe additional 10 minutes, we could use that to at least address a couple of questions we received from the audience. Well, some of the people who lined up in the list already left the meeting, so I think that settles. So I give maybe the floor to the first person in line who asked, who is still there, I think. Pelin Hocam, if you could unmute yourself and ask, and the rest you could still put your questions in the chat box, and if you don't have time, we'll just pass it along. Thank you.
Okay, I'll try to be fast. So I'm a faculty member at Middle East Technical University Computer Engineering Department, and a lot of people in our department are also working on NLP tasks. So this is a great project. Thank you for the very nice talk, first of all. I was really wondering how you do the cross-lingual part, because that's the most striking part, one of the most striking parts of the project, I think. And so you're really relying on BERT's ability there, right? Do you add anything else to make it better, or do you just rely on BERT to handle the cross-lingual part of the project?
For now, we have results only for multilingual BERT. We have surveyed other technologies, but we haven't tried them. There is new proposals in terms of models, like bilingual models are better or other stuff, but the gain is less, to be less, because we have a lot of data in English. So the concept is that our data annotation pipeline enable us to cover or learn the concept quite well with these all adjustments, with all these random samples. So therefore, we don't expect any drastic improvement if we use others, because the inter-tutor agreements are already around there.
Yeah. So actually, I didn't know that we're doing some work using NLP too, but we were just doing it on English text. So I wasn't really aware of this multilingual support in BERT actually. Yeah. So people in our department are trying BERT on Turkish text, but they say it does not perform as well as it does in English text. So that's what I was really wondering. So when you were annotating the Indian language, or whichever dialects, they have a lot of dialects, I know, did you translate them first into English? Because what Fırat Hocam showed looked something like that. So the annotators worked on the English translation, right?
No, it happens to be the case that the newspapers that we use, which are the main national newspapers in India, they're already in English.
Oh, okay.
So it's an English of an Indian variety, which has its own quirks and peculiarities, but on the whole, it was thus very easy to work with. And they're brilliant newspapers as well. I recommend you all to have a look. And the Hindu, Indian Times, and New Indian Express were the sources that we used.
Okay, but you did not use the Indian languages themselves then?
Well, right? as far as I know, national newspapers, we try to use national newspapers for each case country as much as possible. The local dialects, local language-based newspapers in India are local newspapers. So national newspapers are, as far as I know, are in English. Well, the biggest ones at least are.
Okay. Okay, one last question. I'm sorry about stealing everybody else's time, but I'm really wondering, because we're doing similar work. So, I mean, not similar in the sense that it's about protests, for applying it to some other fields. So, and just as I was speaking, I forgot my question, I think. Anyways, I'll ask it later so you can continue.
Please, we should be in contact. I'm sure there are some opportunities for collaboration. And
yeah, I'm part of the lab anyway. So Mary is my sister there's always opportunities for collaboration. Thank you, Hocam.
But there is no nepotism, so I'll have to pause you there.
Okay.
Thank you so much for also the question. I think so. I mean, I hope that the other participants who were hoping to ask questions will message you directly in the end, because I think most of them left. If not, please raise your hand, but I cannot see them anymore. If there aren't any other questions, I think with that, we can.
A small question.
Okay, go ahead.
I don't know about the database decisions are to call what that responds to. I don't understand that actually.
I cannot hear
Maybe
you.
Yeah,
I
we
missed
cannot hear you.
Didn't hear your question. Could you repeat it, or maybe if you would rather type it in the chat box, it might be easier.
Yeah. Can you hear me now? No.
Yes.
Yes, we can hear you.
I was asking about the qualities of databases. Erdem Hoca talked about, and there was a quality named recall, and I don't know what that's about, so I wanted to ask. Could you clarify on that?
Is it to me?
So-
Yeah.
I mean, in terms of when you always want to measure the performance of your system, right? And there are two main measures: precision and recall. And you combine these two measures into a macro measure, which is called the F1 score. And precision and recall, you can understand this like this. For example, you find out of a sample, you say that these are positive cases, which means they contain information. They're about protest. So out of the positive cases, what percentage of them are really positive cases is the precision. And recall means there is a real number of real protest events. What percentage of them are you able to identify? Right. So, so these are two different measures. I mean, how accurate you are in terms of your findings is the precision, and what percentage of the real world cases you are able to find is called the recall. And you combine these two scores into an F1 score.
So as to the question about the databases that you mentioned, about whether about their quality, maybe it can be said that Ali and Erdem both talked about random sampling versus keyword filtering. So they give some numbers, those data sets. So we have this precision score, we have this recall score, and we have this F1 score, but they're based on, they're not really based on raw data, raw data universe. So when you keyword filter your data, you train your data with the filtered data, and you test your models on filtered data. So you know that you perform on filtered data. So if your recall is high, which you catch the majority of, or almost all of the positive cases, but you catch the majority of the positive cases in your restricted setting. So we argue, our argument, the change that we introduced to the field is built upon the fact of working with random samples, not keyword filtered data, so that you can measure your performance in an unrestricted, more natural setting.
Can I ask another quick question? So do you do the evaluation on documents or on paragraphs, sentences? So if a document, like if a whole document has a protest event, do you count that as a positive case, or do you evaluate each and every paragraph separately? And I'm not sure how long the documents are either. So maybe documents are only 1 paragraph long, but maybe that's
Shall
not
I take
the
it?
case.
Shall I take it? Yeah, we don't work with paragraphs. The main units are document, sentence, and token. So as to document length, it varies wildly. So it depends on your newspaper, right? So in India, in general, you get an average word count. In certain newspapers, you get a word count. In Guardian, for instance, we worked with Guardian for a while. As you know, if you've ever read Guardian, they have these long, really long stories. So it's not really uniform. And when we do document classification, our whole unit is the document itself. So in some projects, you maybe to manage the amount of data, they introduce certain shortcuts. They work with headlines, spots, or first 2 sentences. You would find in the literature. We opted not to do that because in that protest information to be in the first 2 sentences, that idea is kind of arbitrary. So that you will have an article about the general political situation in a country, for instance, before an election, and towards the end, you will have a protest mention. So if you only concentrate on certain paragraphs or certain sentences, you will completely miss that information. So in order to maximize our recall, which we aim at determining relevant documents, we work with the whole text.
I can answer the technical part for it. We said we use BERT, but it takes at maximum 512 tokens. By the way, tokens are like things like words, basically. But when we are training, we are using the first 500 tokens, but when we are testing or predicting a document's class, we basically chunk a document into 500 length parts and then predict their class and then logical order them, and get the final label.
Okay, thank you.
Well, thank you very much. I mean, this is a really thought-provoking research, so it's only natural that we'll have many more questions. I invite all our participants who didn't get to ask questions to email our speakers directly. Thank you again so much, also on behalf of GLODEM, for this excellent presentation and for sparing time for it. Our next seminar is actually 2 weeks from now again. Deniz Juret from our computer engineering department will be presenting. So mark your calendars already. And thank you all very much. And I'll stop recording now.